As you know that I am doing strength of material previous year questions, which is exams like GATE, IES and IAS. Today topic is moment of inertia and centroid. I have already completed a lot of lectures based on previous year questions. Okay, so if you are new in this channel, so please watch those videos as well. This will be helpful for mechanical engineering students and for the civil engineering students, and obviously for them who has strength of material as one of the subject. This is about myself. Okay, so we'll see today's questions. So the first question is a moment of inertia. Based on moment of inertia, the second moment of inertia on area of an area. Okay, so let's see that. It's a direct formula based question. The second moment of inertia, the moment of circular area about diameter d is given by. Okay, so pi by 4 d square, pi by 4 d square by 4, pi by 4 d square by 16, pi by 4 d square by 32, pi d square by 64. Okay. So they are asking about second moment of circular area. Okay. So this is actually is nothing but pi d to the power 4 by 64. If you have written a little bit read about strength of material, so you can easily, you already know that. Okay, this is the direct formula. If you solve, I mean, you have already solved a lot of questions, so we have to use actually this formula for many problems. Okay. Question. The area moment of inertia of a square of 1 unit, square size of 1 unit, about its diagonal. Okay. So they are asking about area moment of inertia of a square of size 1 unit about its diagonal. Fine. So we'll see that. So they are asking about this. Okay. About diagonal. So let's say its size is 1. So it's direct formula. Okay. If say the size is a, so about x is moment of inertia is nothing but a to the power 4 by 16. So a is given 1. So if you put here, you will get 1 by 12. So the answer is C. So we have to know that, okay, for any square, the moment of inertia about diagonal is a to the power 4 by 12. Okay, next question, radius of gyration. See, this question is already came in GATE exam 2003. Okay, so this is actually common data problem. So nowadays this type of question is not coming, but earlier they were asking about linked type questions and common data questions. So this is from the common data question. So we have to use this common data for the there will be two problems. So for both the problems we have to solve. We have to use this whatever is given. Okay, so this figure is given. Okay, I will read that. A reel of mass m and the radius of gyration is k is rotating down smoothly from the rest, and one end of the thread wound on its held in the ceiling as depicted in the figure. Okay, so it is held here. So this is the thread. Okay, reel. Okay, and its hub is, I mean, radius hub is r. Consider thickness of the thread and its mass is negligible. Okay, so thread radius and I mean mass and thickness is negligible. They are not considering the mass and thickness of the thread. Okay, so radius is r of hub and a real mass m. Okay, so real of mass is, I mean, mass of reel is m. Symbol G represents acceleration due to gravity. Okay, so they are asking the first question, the linear acceleration of the reel. So these are the options. Okay, see, this question is very simple question. We have to use actually two equations. One is like Newton's second law, okay, and one it is rotating. So this torque concept we have to use. These two concept will solve the whatever two problems is given in this, we can solve. Okay, so we'll see that. Okay, so see, this is the free body diagram of the given figure. So mass will act downward. Okay, so tension will like this thread. Okay, so okay, so for downward linear motion, okay, so let's say acceleration is f, linear, linear tangential acceleration is, let's say, f, that is, r alpha, that will be r alpha, okay, because linear acceleration is not actually moving. I mean, जैसे जो न्यूटन्स लॉ ऑफ सेकंड, न्यूटन्स सेकंड लॉ होता है f इज इक्वल टू एम है, ठीक है, तो उसमें ए जो होता है वो इट्स नॉट ऐसा आर अल्फा नहीं होता है, ओके, बिकॉज इसमें रियल है, it's like absolute in that case, but here we have to consider actually linear tangential acceleration, okay, because from this point it is opening, the reel is opening, so that's why we have to consider the r into alpha, okay, alpha you can say that the rotating acceleration. So this we have to keep in mind. Okay, so the first equation will be mg minus t is equal to mf, this is the same, this f is equal to ma, Newton's second law. Okay, and second equation, rotating motion. Okay, so let's say this t is tr is equal to I alpha, okay, because this is actually one more equation from the rotation we will get. So these two equations we have to use and we will get the answer. Okay, so now so t we can write this I alpha. Okay, so t from this equation, we can write this I is what? It is this k is radius of gyration. We have seen in the statement. So I is mk square, that we know that. Okay, and alpha will be, okay. So from here we'll get the alpha is f by r. We'll put here, and r, if we keep r downward here, so we'll get t is equal to mk square into f by r square. So this is the one equation, okay, from here, and the second equation is this equation, which is here, mg minus t is equal to mf. Okay, so from this is, let's say this is equation number 1, okay, and this is equation number 2. I mean, not this one, okay, equation number 2, okay, this is not this one. So if you just eliminate t, if you eliminate tt from both the side, like if you put t here, okay, and solve for f, if you solve for it, you will get f, this, okay, so you will get f is equal to gr square by r square plus k square. ठीक है, कुछ भी नहीं है, इतना आपको कॉम्प्लिकेटेड लग रहा होगा, बट इट्स अ वेरी सिंपल क्वेश्चन. सो फर्स्ट वी हैव टू यूज Newton's second law from here. So mg minus t is equal to mf, and linear acceleration is like f, that is r alpha, okay, a is alpha is rotational acceleration. So another equation is tr for the rotation, tr is equal to I alpha. So from here we will get t is equal to this, and this t we have to put here, we will get f. Okay, and in the next question they are asking t. Okay, so once you get f, you put this f here, okay, you will get t, that's it. Next question, actually they are asking the tension in the thread. Okay, so that f what you have calculated, just put into the equation of the t, you will get the, okay, so here I am saying this is the expression for the tension, that is t is equal to mk square into f by r square. Okay, so f value we have calculated this much. Okay, we have already calculated r square, this value is already, we have already calculated, just put here. Okay, so if you simplify, you will get mg k square by r square plus k square. Okay, so the answer is C here. So this is kind of common data question they have asked in the GATE exam. Very nice question. There is some concept of it is actually engineering mechanics question. is nothing related to strength of material, but in strength of material lot of things is coming from engineering mechanics, because we have to do the calculation for reactions and all those things. Okay, so strength of material actually, uh, in strength of material lot of concept, I mean engineering mechanics concept, we have to use a lot more here. Okay, question we'll see that assertion reason question. What is saying? Inertia force always act through the centroid of the body and is directed opposite to the acceleration of the centroid. Okay? It has always a tendency to retard the motion. See, uh, inertia force always acts through the centroid, yes, of the body and is directed opposite to the acceleration of centroid. Yes, ये correct है. It has always tendency to retard the motion. No, ऐसा नहीं होता है. Okay, so the answer is C. C is not D. C. Okay, next question. देखिए ये भी it's a formula based question. इसमें ऐसा कुछ बताने वाला है नहीं. ठीक है. It's just a formula, radius of gyration. अगर ऐसा कुछ figure होता है तो okay, we'll see that what they are asking actually. The figure shows the rigid body of mass m having radius of gyration k about its center of gravity. It is to be replaced by an equivalent dynamical system of two mass placed at A and B. The mass at A should be. Okay, so they are asking here. Okay, so it is actually direct. It's a direct form. It is actually B into m upon A plus B. I think you can also very easily solve this question. So you can just solve. I don't think this much explanation is needed for this question. Wherever is required, I will tell that. You can easily solve this question. The answer is B into m by A plus. Okay. Next question. This is also formula based question. A force required to accelerate a cylindrical body which rolls without slipping on a horizontal plane. Mass of cylindrical body is m. Radius of the cylindrical surface in contact with plane is r. Radius of gyration of the body k, and acceleration of body is. Okay, so here they are asking acceleration of body is. So it is actually A. See, this is common data वाला क्वेश्चन जो हम लोगों ने देखा था, उसी टाइप का ये क्वेश्चन है. ठीक है, आप वहाँ से एक्सेलरेशन जो हम लोगों ने वहाँ पे एक्सेलरेशन निकाला था, उसी तरीके का यूज़ करना है. एंड यू कैन सी हियर ऑप्शन भी कुछ उसी टाइप से है. तो यू कैन यूज दैट कॉन्सेप्ट हियर एंड सॉल्व फॉर एक्सेलरेशन ऑफ बॉडी. सो द आंसर इज ए हियर. This is also formula based question. A body of mass m, radius of gyration is k, is to be replaced by two masses m1 and m2 located at a distance of h1 and h2 from the CG of the original body. Okay? An equivalent dynamic system will replaced if h1 plus h2 is equal to k, h1 square plus h2 square is equal to k square, h1 h2 is equal to k square, and root of h1 h2 is equal to k square. So its answer actually C. Okay, k is equal to root of h1 h2. Okay, so h1 h2 is equal to k square. It's direct formula, so you can just use this. I mean, if you know, it's fine. If you don't know, please remember from here. Okay, so next question, based on radius of gyration, a wheel of centroidal radius of gyration is k, is rolling on horizontal surface with a constant velocity. It comes across an obstruction of height h. Because of its rolling speed, it just overcome the obstruction. To determine, one should use principle of conservation. Okay, तो इस केस में हमें क्या विच कौन सा प्रिंसिपल यूज़ करना है, एनर्जी यूज़ करना है, लीनियर मोमेंटम यूज़ करना है, लीनियर एंड एनर्जी एंड लीनियर मोमेंटम यूज़ करना है, एनर्जी एंड एंगुलर मोमेंटम यूज़। ओके, सो इसमें कुछ नहीं, हमें ऐसे केस में दिस इज द डायग्राम बेस्ड ऑन वट एवर इज गिवन हियर. Okay, so we have to use actually energy conservation. The answer is A. Okay, so this was the end of the few problems from moment of inertia and this radius of gyration. Okay, so I hope you like that. Next class will come up with some more problems. Thank you for watching. Bye bye.